Welcome to the debate. It is Friday, January 23rd, 2026. We're currently standing at what I would call a precarious, perhaps even a defining juncture in the history of aerospace. As we sit here today, SpaceX has effectively secured a stranglehold on the orbital launch market. Depending on whose metrics you trust, mass to orbit or sheer launch cadence, they are controlling somewhere between 87 and 98% of global activity. They are the monopoly. But the conversation dominating the industry right now, certainly in the break rooms and the boardrooms, isn't just about SpaceX's dominance. It's about the philosophy required to break it. We are looking at a collision between two very, very distinct schools of thought. The battle-scarred, operational heritage of companies like Rocket Lab versus the AI-driven additive manufacturing promises of challengers like Relativity Space.
It really is the classic hardware versus software battle, and it's finally hitting the launch pad. And I think the framing here is critical because we aren't just talking about who builds the next rocket to compete with the Falcon 9 or Starship. We're talking about how that object is brought into existence. The central question for me is whether the traditional human-led engineering loops, the ones that got us to the moon and built the shuttle, have they hit a mathematical ceiling? I'm arguing that the AI revolution, specifically the deep integration of generative design and large-scale 3D printing, is the only mechanism capable of catching up to a monopoly that has a 20-year head start.
And that is exactly where I find myself deeply skeptical. I represent the position that in spaceflight, the only currency that really matters, the only thing that pays the bills and keeps the lights on, is flight-proven reliability, operational heritage, scars, as the old Apollo engineers used to say. So I argue that the vertical integration and the methodical iteration we see from Rocket Lab, and indeed from the early days of SpaceX itself, are the only proven path. I look at these tech-first manufacturing methods, these claims of printing rockets from code, with a high degree of caution. Physics is unforgiving, and frankly, you cannot code your way out of a gravity well.
See, I come at it from the complete opposite angle. I believe we are witnessing the Nokia moment for traditional aerospace. The argument is that human-led iteration it's too slow for the next phase of the space economy. You cannot iterate hardware at human speed when the demand is scaling exponentially. With players like Eric Schmidt now at the helm of Relativity Space as of last year, and you have companies like Leap 71 generating engine blueprints in hours, not years, hours, the speed of innovation is about to decouple from human cognitive limits. I believe the AI-designed rocket will inevitably leapfrog the incumbents regardless of their current market share, because the rate of improvement is logarithmic, not linear.
Well, let's get into the reality of the landscape today. I want to start by looking at the scoreboard, because in this industry, you are only as good as your last launch. As of the close of 2025, SpaceX achieved 96 launches in a single year. 96. They have essentially monopolized NASA and Pentagon contracts. And here is the kicker for the AI argument. Elon Musk has specifically stated, on record multiple times, that Starship, the vehicle currently revolutionizing heavy lift, was designed without AI. It was built on human ingenuity, rapid prototyping, and, well, blowing things up in a field in Texas until they worked. That is the gold standard. When I look at the field, the only other entity that approaches that level of seriousness is Rocket Lab. They have over 80 launches of the Electron. 80! They understand logistics, range safety, and the daily grind of operations. That is a moat that I don't think a 3D printer can bridge.
I see why you emphasize the current numbers, but you are looking at a snapshot of the past. SpaceX dominates today because they started 20 years ago using the best methods available then. But look at the velocity of the inputs. We are seeing a fundamental shift in how we approach the problem. You mentioned Musk not using AI for Starship, but look at the new entrants who don't have 20 years to burn. Leap 71 is a prime example. They are designing full-flow staged combustion engines. For the listeners who aren't propulsion engineers, that is the holy grail of engine cycles, where you run all your fuel and oxidizer through the preburners to drive the turbines. It is notoriously unstable and incredibly hard to design because the thermodynamics are just brutal. Leap 71 is using algorithms to generate that geometry in hours. They are claiming they can produce these engines cheaper, with fewer parts, and higher efficiency than a Raptor.
Claims are one thing, flight is another. We've seen plenty of paper rockets with incredible specific impulse numbers that never left the hard drive.
Sure, but the inputs matter. And then look at relativity space. The entry of Eric Schmidt, the former Google CEO, taking over as CEO in 2025 wasn't just a personnel change. It was a signal to the entire market. It signals that aerospace is becoming a software problem. The thesis is that if you can digitize the factory, you can iterate at the speed of code, not the speed of tooling. That is how you catch up. You don't build a better factory. You code a factory that builds a better rocket.
That brings us perfectly to our first core disagreement: manufacturing philosophy. The iterative versus the generated. You talk about digitizing the factory, but let's look at the challenger's dilemma. My biggest critique of the relativity model and this reliance on the Stargate printers is that it introduces a manufacturing bottleneck that doesn't exist in traditional assembly lines. And we have proof of this friction. Relativity pivoted. They abandoned the dream of the 100% 3D printed rocket for the Terran R. They moved to a hybrid model, printing the hard stuff but using standard metal bending for the easy stuff. To me, that is a concession. It proves that traditional methods exist for a reason. They're efficient.
I just don't view that pivot as a concession. I view it as extreme agility. That is exactly what the AI-driven model promises. They realize that printing a simple cylindrical fairing or a propellant tank might not be the most efficient use of the printer time, so they stopped. But they are still printing the complex high-value components like the Aeon R engines and the thrust structures. And this is key. Printing allows for design changes that would take SpaceX or Rocket Lab months of retooling to implement. If the AI detects a combustion instability in a simulation, they can print a modified injector plate the next day. They aren't waiting for a new die-cast mold to be machined in China and shipped over. The goal isn't just a rocket, it's, to borrow a phrase, the machine that builds the rocket. By letting AI optimize the factory flow, Relativity is building a system that improves itself and is fundamentally different from a static assembly line, where once you bolt down the jigs, you are committed to that design for 5 years.
I'm not convinced because it assumes that the machine that builds the rocket produces a better product. Complexity in aerospace usually leads to failure modes that are, well, they're impossible to predict in a simulation. Rocket Lab produces components using carbon composites. These are advanced, lightweight materials that are flight-proven. The printed materials Relativity uses for the Terran R, largely proprietary aluminum alloys, are often heavier than the optimized carbon composites Rocket Lab is using for Neutron. So you're carrying dead weight into orbit in the name of manufacturing innovation. That's a physics penalty. A heavier rocket means less payload, which means less revenue per launch. You are paying a tax to use the cool new technology.
There is a weight penalty, sure, but the trade-off is rapid iteration and thermal performance. They are using alloys like GR-COP42 for the combustion chambers, a copper-chrome niobium alloy developed by NASA that is absolutely fantastic for heat conductivity, but nearly impossible to machine by hand. You have to print it. This allows them to run the engines hotter and harder than traditional materials allow. So yes, the tank might be slightly heavier, but the engine is higher performance. And frankly, the proven status of the traditionalists is looking a little shaky right now. This brings us to the elephant in the room. We need to talk about what happened 2 days ago.
I had a feeling you would bring this up. It's the talk of the town.
I have to. January 21, 2026. Rocket Lab's Neutron Stage 1 tank ruptured during hydrostatic pressure testing. For those listening, that's when they fill the tank with fluid and pressurize it to simulate flight loads plus a safety margin. This is the adult in the room, as you called them. This is the company with the 80 launches. They just lost a test article for their flagship vehicle. It's a significant setback. Now contrast that with the momentum at Relativity Space right now. As of late January 2026, their Stage 2 tank for Terran R passed acceptance testing. They have 6 Aeon R engines firing simultaneously at NASA Stennis. The risky AI startup is hitting hardware milestones while the stable incumbent is cleaning up a ruptured tank on the factory floor.
That's a compelling narrative, but let's add some context before we write Rocket Lab's obituary. Space is hard. SpaceX blew up prototypes constantly. A tank rupture during structural qualification is exactly why we test. It's better to burst a tank on the stand than on the ascent with a customer's satellite on board. I don't view the Neutron incident as a systemic failure. I view it as rigorous engineering. They pushed the composite structure to the breaking point to validate their models. Rocket Lab has the capital and the experience to fix that and move on. My concern with relativity is that their momentum is largely optical. Yes, they have engines on a stand, but let's look at the scoreboard again. Relativity has launched exactly one rocket, Terran 1, in 2023, and it failed to reach orbit. They have zero orbital data. Rocket Lab is generating revenue today with Electron. They are launching satellites while fixing Neutron. Relativity is burning cash with no revenue flights.
They're burning cash, but they are backed by serious capital. Over $2.4 billion, with deep pockets like Fidelity and BlackRock, and now with Eric Schmidt, they have the runway. But I want to push back on the optical success. Firing 6 engines simultaneously at Stennis is not a photo op. That is an integrated systems test. That is the hardest part of stage development aside from launch itself. Dealing with the acoustics, the vibration, the fluid dynamics of feeding 6 hungry engines, that is real engineering. And regarding the neutron rupture, yes, testing breaks things. But Rocket Lab's timeline was already slipping. It went from 2024 to 2025, and now with this rupture, 2026 is looking very tight, possibly slipping to late in the year or beyond. Meanwhile, Relativity is strongly indicating a launch in the second half of 2026. If the unproven AI company puts a medium-lift rocket on the pad before the veteran, that is a paradigm shift.
If they launch, and if it works, reliability is a harsh mistress. But let's zoom out to the capabilities, because this leads to our third topic: performance, payload, and the AI ceiling. Let's assume both rockets fly. Terran R is targeting about, 23,500 kilograms to low Earth orbit in reusable mode. Neutron is targeting roughly 13,000 kilograms. On paper, Relativity has the bigger truck.
Exactly. And that payload class is critical. 23.5 tons puts Terran R much closer to Falcon 9 performance, which makes it a direct competitor for mega-constellation deployments. Neutron's a bit smaller, optimized for a specific slice of the market, mostly heavy single satellites or small batches. But the real differentiator here isn't just the kilogram number, it's the optimization. AI, specifically reinforcement learning, is now being used to optimize flight trajectories and fuel usage in ways human planners can't quite match. We are seeing this with startups like Stoke Space, backed by Sam Altman, by the way, who are integrating AI into the very logic of how the rocket flies, how it throttles, how it makes entry decisions.
I see the utility there, but I have to ask the uncomfortable question. Does any of this matter in a world where Starship exists? SpaceX is targeting full reusability and a cost of roughly $100 per pound. If Musk achieves even half of that efficiency, a 3D printed rocket and a carbon composite rocket are both economically obsolete. Starship is designed to be a generic heavy lifter that just crushes the price floor. It's the physics of economy of scale. Whether you printed your engine or hand-polished it, if SpaceX is flying 100 tons for $10 million, you're fighting for scraps. You are the local courier trying to compete with a freight train.
That is the common wisdom, but I disagree. The market doesn't want a monopoly. The Pentagon certainly doesn't want a monopoly. They need assured access to space from different providers. And frankly, the orbital AI data center concept, which Stoke Space and others are looking at, requires an ecosystem. We are seeing a convergence where AI isn't just designing the rocket, it's the customer. The demand for space access is going to explode, driven by these very AI systems needing orbital infrastructure for energy, for data processing, for observation. And regarding Starship, it is a massive, complex beast. There is plenty of room for a nimble, medium-lift competitor that can launch on demand. Relativity's 3D printing allows them to scale production up or down based on that demand, much faster than a fixed assembly line. If the market shifts, they just change the software file. SpaceX can't do that with Starship's massive localized infrastructure.
I'm not sure I agree with the idea that they can just change the file. That trivializes the immense certification processes required for flight. If you change a printed part, even slightly, you have to requalify it with the FAA, with the Range Safety Office, and with your insurers. You can't just upload a patch to a rocket engine hardware like it's an iPhone app. This is where the software mentality clashes with aerospace reality. Regulators need frozen configurations. This is why I stick with Rocket Lab. Even with the tank rupture, they have a process. They have a track record of navigating the bureaucracy of flight. Relativity is essentially a tech company trying to learn aerospace. Rocket Lab is an aerospace company that uses tech. That distinction matters when you are sitting on top of 1 million pounds of explosive propellant.
It matters until the tech company figures it out. Look at the automotive industry. Tesla was a tech company trying to learn cars, and everyone said they couldn't build a panel without gaps. Now they've revolutionized manufacturing with the Gigapress, casting entire frames in one shot. Relativity is applying that same Gigapress mentality to rockets, and I think we are underestimating the Eric Schmidt factor here. Having that level of operational discipline combined with a Silicon Valley software ethos is a potent mix. He didn't step in to manage a science project, he stepped in to scale a business. The fact that they have a backlog of over $3 billion, largely signed before the rocket even flies, tells me the market believes in the AI model. They are betting on the algorithm.
A backlog is not a launch. I'll remind you that countless space startups, Virgin Orbit, Astra, had impressive backlogs right before they went bankrupt or pivoted into oblivion. But let's look at the engines again. You mentioned Leap 71 earlier. The idea of generating an engine in hours is fascinating, I admit. But how does that translate to reliability? An engine designed by a human has intent behind every curve. We know why the cooling channel goes left instead of right. An engine designed by an AI it's an optimization of parameters. If the AI hallucinates a structural flaw, or rather misses a fatigue mode that isn't in its training data, we get a failure. We don't know what we don't know with AI physics models yet. We rely on training data, and we don't have training data for 3D printed materials vibrating at hypersonic speeds for 5 minutes.
That's a fair concern, but it ignores the testing loop. You don't just fly the AI design blindly. You print it, you fire it, you feed the data back into the model. That loop is what Relativity and Leap 71 are closing, and they are closing it faster than human engineers can. The Eon R has thousands of seconds of runtime at Stennis. Those aren't hallucinations, that is hot fire. The data is real, and the efficiency they are finding allows them to push thermal limits that traditional engines struggle with. They are building hardware that literally cannot be built by traditional means because the geometry is too complex for a CNC machine.
Higher performance is great, but let's talk about the timeline again. We are staring down the barrel 2026. You mentioned late 2026 for Relativity. Rocket Lab, despite the rupture, is still aiming for 2026, perhaps Q4. We are effectively in a dead heat. The advocate in me says, bet on the jockey, not the horse. Pierre Beck has taken a company to orbit 80 times. He has recovered boosters from the ocean. He has launched missions to the moon for NASA. Tim Ellis and the Relativity team, while brilliant, have launched one rocket that didn't make it. When the pressure is on, when the tank ruptures, and Relativity will have their own tank ruptures, metaphorically or literally, I trust the veteran team to recover faster.
And I trust the superior system to recover faster. The difference is that if Relativity blows a tank, they print a new design in a week. If Rocket Lab blows a tank, they have to retool the composite layup molds, cure them in an autoclave, and go through a much longer physical cycle. Carbon fiber is amazing, but it is slow to prototype. The recovery time for the AI-driven manufacturing model is inherently shorter. That is the Moore's Law effect I'm talking about. We are trading capital expenditure for speed, and in a race against SpaceX, speed is the only thing that keeps you alive.
Speed is good, but direction is better. If you are sprinting in the wrong direction because your model was slightly off, you just crash faster. We've seen plenty of agile companies run straight off a cliff. But we are getting close to time, and I want to wrap up our positions because this year is going to answer a lot of these questions for us.
Agreed. It's a fascinating contrast. The proof will be in the plume.
To conclude, I stand by my skepticism. Orbit is the great filter. It separates the pretenders from the contenders. Until an AI-designed rocket flies a customer payload to orbit and successfully lands that booster, it is theoretical. The physical reality of launch stresses, thermal loads, and material fatigue does not care about your algorithm. I believe SpaceX's ecosystem, Starlink, the Mars focus, and Rocket Lab's deep operational heritage provide a moat that software cannot easily cross. Even the best AI cannot cheat physics. I suspect we will see Rocket Lab overcome this recent tank issue and deliver a reliable, if slightly later, neutron, while relativity continues to discover the unknown unknowns of spaceflight.
And I'll conclude with this. The industry is at an inflection point similar to the transition from flip phones to smartphones. The flip phone was reliable, durable, and did its job perfectly. But the smartphone changed the nature of communication. I believe the AI-designed, 3D-printed rocket is the smartphone. It is unproven, yes. It is risky, but with the backing of tech heavyweights and the sheer velocity of iteration we are seeing, look at the engine tests, look at the factory optimization. Relativity is poised to be the SpaceX of the AI era. I urge the listeners to watch the latter half of 2026 closely. If Terran R launches before Neutron, if the printed rocket beats the composite rocket to the pad, the paradigm has officially shifted.
A bold prediction. We will have to wait and see if the Silicon Valley approach works on the silicon carbide reality.
Indeed.
Thank you for joining us on The Debate. We encourage you to dig into the source material. Look at the engine test videos, look at the failure reports, and decide for yourself if you trust the algorithm or the engineer.
Thanks for listening.